Welcome to day 5 of our course on programming languages. Today we will be discussing the key considerations in language design, what makes a programming language successful, and the trade-offs involved in designing them. Let's dive in. Today we will cover several crucial topics. First, we will explore the features of a good programming language. Then we will discuss the trade-offs involved in language design. We will also compare high-level and low-level languages. Lastly, we will take a look at some successful programming languages and analyze their design. A good programming language has several key features that contribute to its success. First, simplicity. It's important that a language is easy to learn and use. Second, expressiveness. Programmers should be able to clearly express their ideas without excessive boilerplate code. And finally, portability. Code should run on different platforms without significant changes. Apart from the basic features, a good programming language also needs to perform well. Performance is crucial, especially for applications that require a lot of computation. Readability and maintainability of code is another important feature. Developers should be able to understand and modify the code easily. Reusability promotes modularity, and finally, safety and security features help to prevent errors and vulnerabilities in the code. In the design of a programming language, there are always trade-offs. For example, performance often comes at the cost of ease of use. High-level languages are easier to work with but may be slower, while low-level languages offer more control and better performance but are harder to use. Similarly, flexibility and safety must also be balanced. Dynamic typing can be more flexible, but static typing offers better safety. Another important trade-off involves simplicity versus functionality. A language can be simple but lack advanced features, or it can be feature-rich but more complex. Additionally, when designing a new language, there's always the issue of backward compatibility. Sometimes sticking to older systems may limit innovation, but it's necessary for maintaining compatibility. Now let's look at the difference between high-level and low-level languages. High-level languages are designed to be closer to human language, making them easier to learn and use. Examples include Python and Java. They allow for faster development but often sacrifice execution speed compared to low-level languages. On the other hand, low-level languages such as assembly and C offer more control over hardware and resources. They enable faster execution but require more effort from the programmer. Low-level languages are more complex and harder to debug, but they are essential for system-level programming where performance is crucial. Let's now look at some successful programming languages. Python is a great example, known for its simplicity and readability. It has become a go-to language for web development, data science, and automation. C, being closer to hardware, excels in system programming and high-level performance applications. And Java, with its platform independence, is widely used in enterprise applications. Other notable languages include JavaScript, which powers most of the web with its event-driven nature. Rust has gained popularity due to its focus on safety and performance, particularly in systems programming. Lastly, Lisp, one of the oldest programming languages, is known for its flexibility and influence on functional programming. Let's dive into some case studies to understand the real-world impact of language design. Take C++ for example. It combines low-level control with high-level abstraction, making it powerful but complex language. The trade-off here is between performance and ease of use, with C++ offering fast execution but a steep learning curve. Go is another language designed for simplicity and efficiency, particularly in modern computing environments. It's easy to learn and works well for scalable applications. Haskell, on the other hand, is purely functional with an emphasis on immutability and strong typing, offering benefits like fewer bugs but requiring a different mindset for developers. Now that we have covered the theory, let's put it into practice. In Activity 1, we will compare Python and C++ to understand their differences, the design decisions that make each language suitable for different types of projects. In Activity 2, we will discuss the trade-offs involved in designing a new programming language. Specifically, we will look at balancing safety and performance, an important consideration when choosing a language for a project. By the end of today's session, you should have a better understanding of the key considerations in designing a programming language. You will also appreciate the trade-offs involved and why certain languages succeed in specific contexts. In conclusion, the design of a programming language has a significant impact on its usability, performance, and suitability for different tasks. By understanding these design considerations, you will be better equipped to choose the right language for your projects and make informed decisions when working with various programming languages.